Today we're talking about solving systems by graphing. Two or more linear equations form a system of linear equations. The solution of the system of linear equations is any ordered pair that makes all the equations true. In other words, when we graph two or more lines, that point where they intersect, that's the answer. So let's say we have to graph y equals 2x minus 3 and y equals x minus 1. I'm going to graph the first equation in red. What is the slope in the first equation? The slope is 2 over 1 and the y-intercept is -3. So let's start by graphing the first equation. So we're starting at -3 with a slope of 2 over 1. I'm going to graph the second equation in purple. The slope of the second equation is 1 and the y-intercept -1. So going to -1 with a slope of 1. Do we see where they intersect already? Yes. We can graph our line. So these lines intersect right here. What's that ordered pair? 2, 1. So that means that the solution to this system of linear equations right here is 2, 1. In other words, if we substitute y with 1, let's say we substitute this y to x minus 3 and y equals x minus 1. If we substitute y with 1 and substitute x with 2, these should both be true. 1 is equal to 1, so that's true. And right here, these are both true, and that's why 2, 1, ordered pair 2, 1, is the answer to the system of equations. We have to solve by graphing y equals x plus 5 and y equals -4x. The solution to a system of equations will be that point where they intersect. So we have to graph both of these. We start with the top one. We're going to graph in red. The slope equals what? 1. And the y-intercept? So we're going to start at 5 with a slope, with a slope of 1. And we're going to graph the next one in blue. The slope is -4 and the y-intercept? Y-intercept is 0. -4, 1, 2, 3, 4, and 1. We can go in the opposite direction. 1, 2, 3, 4, and 1. Did we find where they intersect? Can you already see where they meet? So their point of intersection is right here. What's that ordered pair? -1 and 4. That's the point of intersection. We can check our work. How do we check? Well, we can substitute into each of the equations. Y equals x plus 5 y equals negative 4x. We can substitute y with 4 and x with negative 1. 4 equals 4. This is true. 4 equals negative 4 times negative 1. 4 equals 4. They're both true. That means that our answer is correct. If we have to solve by graphing and we have y equals negative 2x plus 1 and y equals negative 2x minus 1, what do we remember about equations that have the same slope? What type of lines are these? These are parallel lines. Okay. Parallel lines. Do parallel lines ever intersect? No. So because they never intersect, there is no solution. If we were to graph this, it would look something like this. And we can see that these lines do not intersect. We have to solve by graphing. Well, in order to graph these, we can change the top equation to slope-intercept form. I'm going to rewrite it. 2x plus 4y equals 8. We want it to look like y equals mx plus b. I'm going to take 2x to the other side. 4y equals negative 2x plus 8. Going to divide both sides by 4. Y equals negative half x plus 2. Y equals negative half x plus 2. So if you look at the second equation and the first equation, what can you tell? They are exactly the same line. So because these are exactly the same line, there's infinitely many solutions. And if we graph these, we would only be graphing one line because they are exactly the same line. Questions on this?